Pre-statistics. Variables, constants, and data. Lesson objectives. Define and give an example of a variable, a constant, and data. Number 2. Summarize data by using a graph and using the average, or the mean. Lesson objective. We'll begin with the definition. A variable is a symbol which represents a quantity that can vary. For example, we can define h to be the height in feet of a Pacific child. Height is a quantity that can vary, and if you think about it, as time passes, the child's height will increase. Therefore, h is a variable. It can vary. When we say h is equal to 4, we mean that the child's height is 4 feet. Example 1. Here's 3 situations involving the concept of a variable. Let's look at each. Number 1. Let S be a car's speed in miles per hour. What is the meaning of S equals 50? The speed of the car is 50 miles per hour. So when S is 50, that means the speed of the car is 50 miles per hour. Number 2. Let N be the number of people in the millions who work from home at least once a week during normal business hours. For the year 2016, N is equal to 25. What does this mean for this situation? In 2016, 25 million people work from home at least once a week during normal business hours. Number 3. Let T be the number of years since 2010. What is the meaning of T equals 4? Well, since T is the number of years since 2010 and T is 4, we take 2010 and add 4 and we get 2014. So T equals 4 represents the year 2014. When T is negative 10, we take 2010 and we add a negative 10 and we get 2000. So T equals negative 10 represents the year 2000. Constants. A constant is a symbol which represents a specific number. It's a quantity that does not vary. It doesn't change. It stays the same. Here's a listing of some famous mathematical constants. Of course, 0 is a constant. Stays the same. 1 is also. And here we have pi, which is approximately 3.14, and it's always going to be approximately 3.14. It's not going to change. Example 2. A rectangle has an area of 12 square inches. Let W be the width, measured in inches, and L be the length in inches, and A be the area in square inches. Number 1. Sketch 3 possible rectangles of area 12 square inches. Number 2. Which of the symbols W, L, and A are variables? Explain. And number 3. Which of the symbols W, L, and A are constants? Explain. Well, number 1, we want 2 factors that multiply to give us 12, and those factors will be our L and W. The first one is 1 times 12, so the width is 1 and the length is 12. Another one would be a width of 2 and a length of 6. The area is still 12. And the last one, we have a width of 3 and a length of 4, and we have a rectangle that has an area of 12. Number 2, the symbols W and L are variables because they represent quantities that can vary. W, we saw 1, 2, and 3. For the values of L, they varied from 12. The second example was 6, and the last example was 4. So L and W are variables. Number 3, the symbol A is a constant. This is because the area stayed the same, 12 square inches for all 3 examples. Lesson objective. Data. Data are values of quantities that describe authentic situations. We often get a better sense of data by graphing than just looking at the data values. Let's look at an example. Example 3. The following data are responses from a random selection of 25 Cincinnati State students who were asked the following question. How many tattoos, if any, do you have? Here are the responses from the 25 Cincinnati State students. Now in statistics we call this raw data, and it's not easy to look at raw data and get some kind of idea of what the data is telling us. And let's use a graph to summarize this data. So if you think of a number line and we plot each value on the number line, we should get something that looks like this. Here we can see that there's more values of 0 than any other, and as the number of tattoos increases, the frequency or the number of students who have those tattoos decrease. Average or mean. Definition. To find the average or mean of a group of numbers, we divide the sum of the numbers by the number of numbers in the group. So we add up all the values and then we divide by how many we have. What's nice about the average is it allows us to summarize many values into one single value. Let's go to our tattoo example. To find the average number of tattoos for our previous example, we first want to add up the values, and if you take the time to add these 25 values, you should get a sum of 41. Next, we want to divide 41, the total, by the number of students, which is 25. So 41 divided by 25 is 1.64. So we can say that the average number of tattoos is about 1.6 tattoos. Now here's data from a student survey which asked all Cincinnati State students taking Stats 1, how many tattoos, if any, do you have? We have a total of 115 students here, and actually this symbol here represented there was one student who did not answer the question. So what would this look like in a graph? Well, like before, this is what we call a dot plot. And as we can see, there are more students with no tattoos than any other. And as the number of tattoo increases, the number of students who have that number of tattoo decreases. Another graph that we could use to summarize this data is something called a histogram. And again, we can sort of see the shape of the distribution just like with the dot plot. And another example of a graph to summarize this data is what's called a individual value plot. And here are the number of tattoos, and the dots here represent a student with that number of tattoos. And again, as we increase the number of tattoos, the frequency gets smaller. And finally, we can summarize the data set by using the mean or the average. So the mean is 1.254, and because we had one student that did not respond, if we were to take the sum 143 and divide it by 114, we get an average or a mean of 1.254. Thanks for watching.